All right, good afternoon, everyone. Again, welcome back. We are about to begin the session, Planning for Fire Safety. My name is Clarence Mikas. I'm part of the working group and look forward to this time. Our presenter for this session is Nathan Hill. A little bit about Nathan. Nathan is a Cayuga Nation wolf clan from the Six Nations of the Grand River Territory. He is a fire safety coordinator and infrastructure specialist with Ontario First Nations Technical Services in Ontario. He provides First Nations communities throughout Ontario with technical advisory services for various fire protection and fire prevention issues. He also completes new construction inspections on residential dwelling units on a few First Nations communities in the south of Ontario. Nathan obtained a construction engineering technician college diploma from Mohawk College in 2011. Nathan is a certified building code official from the Ontario Building Officials Association in Ontario since about 2018. He is also site basic certified inspector with the Wood Energy Technology Transfer since about 2015. In his spare time, Nathan operates a small woodworking business, Naughty Nate's Woodworking, which was started in 2004 as a summer business. So welcome today. There's a chat open. There also is a question area and answer, and hopefully we can get to that towards the end of the session. So let's give our time to Nate. Thanks everyone for attending.
Scano. Hello, everyone. As Clarence had mentioned, my name is Nathan Hill. I'm a fire safety coordinator / infrastructure of the Ontario First Nations Technical Services Corporation. Clarence also mentioned I'm a wolf clan of the Cayuga Nation from Six Nations of the Grand River Territory. Coming to you live today from my home in Brantford, Ontario. I'm very grateful to the event organizers to have the opportunity to present here today. So the title and theme of today's presentation is Planning for Fire Safety. Fire safety is something that's very important to my role in the Fire and Safety Program with Ontario First Nations Tech Services Corporation. And there's definitely a relationship between fire protection and housing in First Nation communities. Throughout the presentation, I encourage you to think how planning for fire safety relates to the theme of this year's event, building healthy homes. I'd also like to mention that I have two polls on the right side of your screen there. First poll, how many working smoke alarms are installed where you live? Second poll is, do you have a working carbon monoxide alarm where you live? So please take the time to answer to those. I'll be pulling the results up throughout the presentation here. So planning for fire safety, what does that mean? And how do you plan for something if you have no idea if and when it might happen? Well, planning in the title refers to the planning stage during the pre-construction phase of a project. Obviously, there's no accurate way to determine when an emergency, such as a fire, might occur when a home is already built and occupied. And you're not able to control what someone does inside a home in regards to fire prevention practices. Fire prevention is always the most important and most effective way to practice fire safety in your community. From a construction perspective, the ideal approach is to plan accordingly and prepare the home so you can best prevent potential fires from happening in the first place, and the systems in place can either notify the occupants in the event of an emergency or delay the process long enough to allow people to escape. During this presentation, I will focus on specific areas where fire protection plays a very important role during the planning phase. I will try to highlight some differences in fire protection requirements between the 2012 Ontario Building Code and the 2015 National Building Code of Canada. Unfortunately, I will not have time to discuss every fire protection related requirement in both building codes. I will be trying to highlight major items that I've come across in my experience working in First Nation communities. If you're not familiar with either version of the building code or have specific questions about your project, please discuss these items with your contractor, builder, architect, designer, or anyone else involved in your construction project. Lastly, I just want to make it clear that these are not the only ways to address some of these issues. There's a large variation in how someone may address or interpret these items, and the information in this presentation is only my interpretation. So you may even ask yourself, why focus on fire safety? There are usually numerous other areas where time and resources can be focused on during construction. Some other areas could include energy efficiency, air tightness, insulation levels, structural integrity, quality or type of finishes, as well as numerous others. Why is your time and resources best spent focused on fire protection as opposed to those other areas that were just mentioned? Well, according to a study completed by Statistics Canada in partnership with the National Indigenous Fire Safety Council and the Aboriginal Firefighters Association of Canada, a First Nations person living on reserve is over 10 times more likely to die in a house fire when compared to a non-Indigenous person living off reserve. With that statistic and the theme of this year's event being building healthy homes, you can see why fire safety is such an important consideration during a construction project. The link to the study is shown here on my presentation, but I'll also make sure that information is available for everyone else. So now let's get into some specific requirements that are related to fire protection in houses. First off is an important one is smoke alarms. Again, I'd encourage everyone to answer the poll questions that are available, and we'll be pulling up the results from those to get an idea of where everyone's at currently. You can see on this slide that some of the requirements for smoke alarms are in the same location in both the Ontario and national building codes. This section of the presentation will focus on the requirements of the Ontario Building Code specifically. Any slide that shows building code references only shows a portion of the information. There are usually numerous other building code areas of the building code that would apply, but I'm only able to focus on a few areas during this presentation. So here we have a floor plan of a 3-bedroom house with an attached garage. I'll be using the same floor plan for most of the examples throughout this presentation. So hopefully you'll be able to follow along and visualize these requirements as they pertain to this specific floor plan. This floor plan does not show stairs to a basement or a second story. For the purposes of this presentation, let's all just assume this is a typical 1-story slab on grade type construction. The most important consideration in regards to smoke alarms is their location. So where would you be required to install smoke alarms in a unit such as this one? Well, both the Ontario and national building codes require smoke alarms to be installed inside each sleeping area. Personally, I would consider any room that is generally the size of a bedroom with a door that closes it off from the rest of the space and could potentially be used for sleeping in the future to be considered as a sleeping area and may require its own smoke alarm, even if the room is labeled as an office or any other similar use on a set of drawings. Since this is just a 1-story unit, where else would smoke alarms be required? Well, I'll let you know that I chose this specific floor plan for a reason. Notice how the floor plan shows 2 bedrooms on the right side of the plan and 1 bedroom on the left. They're separated by rooms such as a great room, kitchen, among others, and bedrooms on either side are served by their own hallway. Both the Ontario building codes are clear in the fact that they require smoke alarms to be installed in a hallway if the bedrooms are served by a hallway. And generally you'd require at least 1 smoke alarm on any story. Both codes would also require a few other things, such as the alarms to be installed with permanent connections to an electrical circuit with no disconnect switch, installed with battery backup that can provide power to the alarms for a period of not less than 7 days. All alarms must be interconnected so that if one alarm is activated, they will all sound. Alarms must be required to be installed on or near the ceiling. Alarms must follow a certain temporal sound patterns or a combination of sound patterns and voice relay. Alarms are also required to be installed with a visual signaling component, basically consisting of a bright flashing light that would activate when the alarm sounds. Now at this point, would we be able to pull up the results of the first poll question regarding smoke alarms? So you can see here how many working smoke alarms are installed where you live. Nobody said 0, that's perfect. 1 to 2, 3 to 5, 5 plus, or unsure. So there's no right answer, there's no wrong answer. It all depends on which house, when the house was built, things like that. It's good to see that people have them. Okay. Now moving along to carbon monoxide alarms. So for anyone who may not be familiar, carbon monoxide, or CO, is a colorless, odorless, tasteless, poisonous gas produced by incomplete burning of carbon-based fuels, including gas, oil, wood, and coal. So does every house built under the Ontario or National Building Code require a carbon monoxide alarm? Generally speaking, the two instances where you would require a carbon monoxide alarm would be firstly, a fuel burning appliance such as natural gas, propane, or oil furnace, hot water tank, even a stove, something like a solid fuel burning appliance such as a wood stove or fireplace. Secondly, would be an attached storage garage, attached garage to the house. You can see that the requirements, some of the requirements for carbon monoxide alarms are located within different areas within the Ontario and National Building Codes. So the floor plan shown earlier shows an attached garage, which would trigger the requirement for carbon monoxide alarms inside this building. You will see smoke and carbon monoxide alarms installed as combination units. More often than not, that's what I would typically see, as opposed to separate smoke alarms and separate carbon monoxide alarms. So this is assuming that there would be the 5 smoke alarms installed in the same floor plan shown earlier. So which alarms could be installed as those combination units? So you'll see there, the red are typically just going to remain as the smoke alarms, and the yellow circles would typically be those combination smoke and CO alarms. So you'd still have the 5 alarms. Neither the Ontario or National Building Codes specifically require a smoke or a carbon monoxide alarm, to be installed inside sleeping areas. Under the Ontario Building Code, carbon monoxide alarms are required to be installed adjacent to each sleeping area. It could be in a hallway like you see here, and generally that would more often than not meet those requirements. Under the National Building Code of Canada, you would have the option to install carbon monoxide alarms inside sleeping areas or outside sleeping areas within 5 meters of any bedroom door. Some contractors may just install combination CO and smoke alarms in every location, which I think is a good practice. Both codes are specific that carbon monoxide alarms are installed at the manufacturer's recommended height. In the instance of a combination smoke and CO alarm, that would most likely be on the ceiling, but you always want to make sure that you install they're installed as per the manufacturer's specifications and recommendations. Now, are we able to pull up the poll results for the second question regarding carbon monoxide alarms? See there, 79%, 11 showing that they do have one, and 21% saying no. So again, even the no's, not necessarily that they would be wrong or unsafe. If they have electric baseboards throughout, no fuel-fired appliance, then they may not need one. So just something to keep in mind. So next up, I'd like to talk about fire separations. And realistically, this is something that could warrant its own entire presentation. So there's not a lot of time to focus on all the requirements, but I'm just going to focus on a specific requirement today. You'll see here that some of the requirements for dwelling units are in the same location in both the Ontario and National Building Codes. They're not, again, it's not all the requirements, but only a portion. So for this example, we had to switch to a different floor plan, as there would not necessarily be a requirement for a fire separation on that previous floor plan. So this floor plan shows a simple duplex. The duplex is mirrored with a 2-bedroom unit on each side. So which portion do you think would need to be constructed as a fire separation? So you can see there, the red line basically going down the center of that building is what would need to be constructed as that fire separation. For this specific floor plan, the separation would likely need to be designed and constructed to have a resistance rating of 1 hour. Maybe instances where the fire resistance rating would be greater than that, but typically that's what the minimum that you would see in regards to houses and dwelling units. There would be a large number of possible configurations to achieve that required rating, wall configurations, construction configurations, things like that. The point is that each of those configurations would be assigned a minimum rating, and the designer would propose a wall configuration from the tables that are listed in the applicable Ontario or National Building Code, or any building code that they're pulling that information from. Normally what I would see is some combination of wall studs, either staggered or separated entirely with some type of insulation, and even 5/8 type X drywall on each side of that separation. So here's a picture, again, still I'm talking about fire separations, showing a basic elevation, and you're going to see a vertical fire separation in this instance. It's important to remember that the fire separation is required to be a continuous barrier to prevent the spread of flame from the bottom of the foundation up to the underside of the roof sheathing. So for the purposes of this example, let's just assume that this is a slab on grade type foundation with no crawl space or anything. So the red line there shows that the fire separation would typically be required to go from the bottom of that foundation, right from the slab on grade, up to the underside of that roof sheathing. You can see even the attic space is separated. Now again, the same elevation, but just assume it has a crawl space foundation as opposed to a slab on grade. You can see the fire separation will need to extend from the very bottom of that crawl space up to the attic, through the attic to the underside of that roof sheathing. So again, depending on your type of construction, it may be done in various ways. Just the last thing on fire separations I'd like to touch on is when you have a wall between those units, like shown, and you have electrical outlet boxes installed within that fire separation. So here's a plan view of a wall constructed as a fire separation, showing electrical outlet boxes installed. So notice that they're offset They're not installed back to back. And there's also some portions of drywall, that's the blue that's been highlighted, that's been installed within that separation to maintain the integrity. You don't want to install them back to back or where a fire on one side could make its way through to the other side. You want to protect that as much as possible and maintain the integrity of that fire separation. So separation of storage garages. So while a storage garage does not always have to be built with a fire separation in mind, it does always have to be separated from the rest of the interior of the house or building by an air barrier. So what exactly does that mean? So you see, we've switched back to the original floor plan from earlier, and this plan shows that attached storage garage. So you'll see on the floor plan, the walls directly between the storage garage and the living space are walls that would need to be constructed as a separation. Not as a fire separation, but as separated from the remainder of the building with that air barrier. And that's done to prevent the passage of gas and exhaust fumes from the garage into the living space of the house. If someone starts their car in the garage to warm up, you don't want those exhaust fumes and gases making their way into the rest of the living space. Typically, you would achieve this by installing an air barrier system conforming to 925.3 of either the Ontario or National Building Code. If you're not familiar with either building code, so what exactly does that mean? So you'll see on this slide, I took the storage garage away. So let's just imagine, for this example, it doesn't get a storage garage anymore. So since the garage is no longer there, how's that going to change the construction of that red highlighted portion of the wall? Well, normally you'd see that wall constructed as an exterior wall in the same manner as the rest of the exterior walls. That would consist of some type of insulation, 6 mil poly air barrier on the warm side of that insulation. So if you keep that type of construction in mind and put the garage back in place, that's basically what you would expect to see in this scenario, that air barrier keeping those gases separate. Keep in mind that if this, hypothetically, if it was a 2-story building with living space above, any room directly above that garage, that floor/ceiling assembly would need to be required to be constructed as an air barrier in a similar manner. So if you have a bedroom or something above that storage garage, you'd have to keep that in mind as well. So you'll see an additional code reference that I've placed on the slide there, 910.13.15, with an arrow pointing to the door. The door leads from the garage into the living area, into the living space there. So that specific code requirement basically indicates that you'd have to have a tight fitting weather strip door to prevent the passage of gases and exhaust fumes, and that door also must be fitted with a self-closing device. The self-closing device is going to ensure that the door closes on its own when it's not in use. Typically, what I would expect to see is a metal insulated door, similar to what you would see installed as an exterior door anywhere on a typical house. If that door between the garage and the rest of the house has a openable window, like a front egress door might, then that might be an issue, right? I think you'd want just a typical solid core insulated door, just to prevent any issues in the future. Another thing to keep in mind, that the door leading from the attached garage into the living space cannot open directly into a bedroom or any other room intended for sleeping. So you'll see on this floor plan, it opens up into a hallway, not into a bedroom or anything like that. So there'd be no issue with that, but it is something to keep in mind. Another one I want to touch on is egress doors, egress windows or doors for bedrooms. It's something I've come across as an issue in a number of inspections and can present a potential safety hazard in the event of a fire. You'll see the basic kind of requirements are in the same location in both codes there. And this is one that varies between both the Ontario Building Code and the National Building Code. So I want to kind of bring that up. The measurements listed on this slide are the same in both the Ontario and National Building Code, but when an egress window would be required to be installed is what varies between the two codes. So the minimum dimensions for an egress window would consist of a minimum openable area of 0.35 meters squared or 3.8 square feet with no single dimension less than 380 millimeters or approximately 15 inches. The window must also be openable from the inside without the use of keys, tools, or special knowledge, and the window must be able to remain open without the need for additional support. You can see on the slide that window A would not be acceptable as it doesn't meet the minimum openable area requirements. Both window B and C would meet the minimum openable area and minimum dimension in both directions. So when are they required to be installed? So 2015 National Building Code of Canada would require that at least one egress window would be required to be installed inside each room meant for sleeping. That is unless the bedroom has a door that opens directly to the outside. So you'll see on our floor plan here, none of the bedrooms have doors that open directly to the outside. See, the windows in green are ones that typically would be required to have those minimum dimensions as mentioned earlier to be considered an egress window. So bedroom number 1 and bedroom number 2 each only have one window. So that window would be required to be installed as an egress window. Master bedroom has 3 windows in total. Not all 3 of them would need to be installed to meet those requirements. Just one window. So the 2 windows shown in red on the top of the slide would not need to meet these requirements. And just keep in mind again that this slide is specific, this slide and this information is specific to the 2015 National Building Code of Canada. Now this slide is specific to the 2012 Ontario Building Code. The Ontario Building Code does not have the same requirement for every bedroom to have an egress window. Since this is a 1-story unit with 3 openable doors on the same floor level, the windows inside the bedrooms would not need to be installed to meet those minimum openable area and egress requirements as mentioned previously. A bedroom would still need a window to allow for natural light, other things like that to meet other parts of the code, but not the egress requirements as mentioned. Just for the sake of argument, if you had a 2-story building with either a basement or a 2nd story and bedrooms on either in that basement or the 2nd story that does not have a door leading to the outside, then those windows typically would need to meet those minimum egress requirements. But on this 1-story example shown here, they would not. And again, that's specific to the Ontario Building Code. In the matter of safety, I would recommend installing an egress window in any bedroom, regardless of which building code you're intending to follow. Again, speaking to safety. And lastly, I want to touch on protection of foam plastics. If you're not familiar with foam plastics, they would normally consist of building materials such as spray foam insulation or rigid foam insulation. Both of these materials are normally very susceptible to fire damage and flame spread. The code references shown on the screen will include some of the requirements I'm referring to, but again, there's quite a bit of information in both of those documents. It will include a list of materials that are acceptable to be installed to protect that material, be installed as a thermal barrier to protect that material. And typically those would be a sheet type material such as drywall, plywood, or OSB, something in that nature. So here's 2 pictures showing spray foam insulation on the left and rigid foam insulation on the right. Typically, these two materials would need to be protected from ignition and separated from the interior of any living space. Realistically, there's a lot of ways to look at this as far as interpretation, but typically if you're in a living space and you can see either that spray foam or foam plastic, typically it would need to be protected with one of those thermal barriers. More often than not, what I would see is a single layer of 1/2-inch drywall. If that's acceptable in your jurisdiction, then that's fine, but it may vary from location to location. The other item to keep in mind in this instance would be a crawl space with an ignition source inside of it. So a crawl space may not necessarily be considered as a living space, not tall enough for someone to live down there, which is still a part of the building. And if you have an ignition source installed inside it, that ignition source may consist of an HRV, forced air furnace, electric baseboard heater, something like that. Most often than not, spray foam or rigid foam insulation manufacturers would require a thermal barrier be installed to protect the foam plastics in that instance, even though the insulation may not be installed inside the actual living space. With something like this, you always want to make sure to follow the manufacturer's specifications and recommendations for any of these particular products. They should be able to provide that information with what would need to be installed. Again, if you have any questions about the information from this presentation, how it might relate to your project that you're planning, please have a discussion with your designer or builder. They should be able to answer how these requirements that I mentioned here relate to your project. I'm hoping that the information from this presentation promotes some thoughts and discussion in how we can build more fire-safe homes in First Nation communities. Again, I'm Nathan Hill of the Ontario First Nations Technical Services Corporation. My contact information is listed here on the screen. And that is all I have. Nyawa. Thank you.
All right, thanks, Nathan. Now we will look at some questions that have been submitted on the Q&A tab of the platform. I'll read a couple of them and I'll let you respond to them, Nathan. One, why are the CO detectors on the ceiling?
Well, I'm assuming basically what I've heard before is that it's typically thought that carbon monoxide is heavier than air and it would go lower to the ground. I've often heard that. From my understanding, basically the science is that when it's been tested, carbon monoxide actually is slightly lighter than air and it will distribute itself evenly within a given space if there's a sufficient amount of it. Not that sometimes you'll see the carbon monoxide alarms that you would plug in. Typically those are installed near the floor because that's where the outlets are. But again, specific to carbon monoxide alarms, if you're buying one, it's going to have its own manufacturer's specifications, and just make sure it's installed as per those specifications.
Okay, thanks, Nathan. Another question that was posted: what if someone is epileptic? Would a strobe light alarm induce a seizure?
I've heard that brought up before. Unfortunately, I can't comment if it will induce a seizure or not. I'm not a qualified medical professional, but if that is a risk that in a specific instance you would you would come across, I think you'd have to have the discussion with that building enforcement department in the community and let them know that that is a concern and see what kind of options are available. Obviously, the code reads as it does, is that a smoke alarm has to be installed with that visual signaling component, as it's referred to, that strobe. But again, I've heard that, and I think that you have to take it as a case-by-case basis where if that presents a serious hazard, then maybe you look at other options. Right?
All right, thanks, Nate. Another question here. There are some safety features on windows, especially in a second-story bedroom, to keep children from falling out. This would be in conflict with egress window standards. So does the egress code rule out over safety of a child falling potentially?
The code, I know one thing the code does make mention of is a minimum height from the ground, like the sill height of that window in regards to safety. So obviously it's what I mentioned isn't all the information. So you'd have to follow that portion of it as well. But again, like you're trying to be as safe as possible, right? So if you're installing something that may present a hazard in another way, then you do have to look at how you're going to handle that and how are you going to go about making the unit as safe as possible. I guess all I can say is that if it's installed and it meets the minimum requirements of whichever code you're following, then it works, right? Normally, you're not supposed to contravene or ignore portions of the code. So I think you do have to be careful in that. And again, even back to the smoke alarms, you can't just ignore parts of the code, even in regards to something like safety, right? So you have to be careful, but definitely, again, make that determination on site and see what can be done.
All right. Thank you, Nathan. There are another question. Would you recommend any fire retardant or fire resistant paints for walls?
I guess it depends. I mean, if it's something that's approved and tested to meet a certain standard and it actually is shown to be effective, yeah, anything in regards to safety. But if it's something that's labeled in a certain way and worded in a certain way where it may not actually do anything, then I think there may be better ways to spend money. But if it's normally a lot of the surfaces inside a house, they have to meet certain flame spread ratings, things like that. I don't want to get too much into that, but typically what you would see is a drywall finished with paint on it, and that's gonna suffice. If there's something out there that's better, then maybe it's worth looking at, right? And again, you're going to be looking at a cost versus what is typical. So anything in the interest of safety.
Yeah, thank you, Nathan. Kind of another question on the window access theme. I have seen some egress windows that meet the minimum requirement per size, but are 5 or 6 feet off of the floor. This seems to defeat the purpose of egress if someone can't climb out. Is there anything in the code that prevents them from being too high?
I don't want to say no because I don't profess to be a code master, if you will. But as far as I know, there's only requirement for a minimum height. Obviously, you don't want it right at the floor level because again, I agree with that at a certain point, if it's too high, then you're not able to access it. There may be something specific in regards to windows in general, where it's not going to be a certain height, but think like a basement, right? Just as off the top of my head, picture a basement scenario with a window. Typically that window might be 6 feet off the ground, the sill of that window. And you know, for all intents and purposes, that would comply. So not to my knowledge, there isn't a minimum or a maximum sill height. There is that minimum sill height, and I guess you're just, again, in the interest of safety.
Thanks, Nathan. I know you're right about, I mean, this is a design and planning focused thing.
Yeah.
Sometimes the application of how these things happen. I know sometimes in planning for fire safety, or, you know, planning with your kids or children, you know, there's ladders you can buy that are made for emergency use, and even a way of getting up to the window, like a dresser or something. These are some things that are covered in planning for home fire safety with children. So, you know, contact your local, you know, volunteer fire department, or a fire safety professional like Nathan. He could get you access to information like that for sure. And Nathan did provide his contact information. I believe he'll also be at the trade show booth tomorrow with Ontario Communications Technical Services. So
if you are interested in the slides or the study information that I mentioned at the beginning, I'll have that information at our trade show booth tomorrow, but you got to come see us to get it.
All right, we're about out of time, so thank you everyone for joining us today. Thank you to Nate. The conference planning working group has offered a gift for the speakers, so Nathan will be getting the gift that will be shown here in a second. So thanks, Nathan, for your expertise and information. Great job. Also, so if you're participating as a delegate, we do there is a passport to prizes again for every session. So go to the homepage on the platform and go to the passport to prizes area, and you can pick the session. And as you can see, the word to put in to submit for the code for this session is plan. So please write that down and then go put that into the area on the passport to prizes to continue collecting towards access to some great prizes later. That is our sessions and event for today, I believe. We will be back at 1 p.m. Eastern time tomorrow. We will have an exciting afternoon together with the Builders Challenge, a popular event, albeit with a different format this year. It'll still be really good. And also the trade show. So tune in again. And thank you everyone for joining us today. Have a good night.